Week 10 by talking about how we can measure energy expenditure. And so here are the objectives we're going to go over for today. There we go. So we're going to define direct and indirect calorimetry as long as RQ, and we're going to compare and contrast, and then we're going to talk about how we can calculate VO2 and VCO2 and RER. So calorimetry is the measurement of heat production. And we do this in order to estimate energy expenditure. Basically what we're doing is we're taking food, we're combining it with oxygen, and that allows us to complete some sort of mechanical work, and it also releases heat. Now, the way we can't really do this. It's very difficult to do direct calorimetry. And so what we use, and what you'll use in lab, is something called indirect calorimetry. And so this is a measurement of oxygen consumption, and we use this measurement to estimate how much energy we're actually expending. All we do is we compare the differences between what we breathe in and what we breathe out with regards to both oxygen and CO2. All right, so there is a formula here. So VO2 equals VI times FiO2 minus VE times FeO2. So wherever you've got an I, we're talking about inspired. Wherever you've got an E, we're talking about expired. VCO2 is the same thing, except for we flip the expired minus the inspired. Now the reason we have inspired minus expired for oxygen is because there's more oxygen in the inspired air. And then we do the reverse for CO2 because there's more CO2 in the expired air than the inspired air. So I want to walk you through an example of how we might calculate this. So if you're doing a treadmill test, we're going to say you're exhaling 100 liters of air per minute. So you're doing a pretty good, this is a fair amount of work. Okay, percentage of oxygen in the inspired air is 20.93% because that's what it is. Okay, but in the percentage of oxygen in your expired air, it's 16%. So how much oxygen are you actually using per minute? All right, and so what it is it's VO2 equals inspired times the percentage of oxygen minus expired ventilation times the percentage of expired oxygen. Okay, and so if you did this, you get this number, and this number is actually wrong. This should be 4.93, not 5.93, because 20 minus 16 is 4. Okay, so I'm going to fix this real quick, at least show you. Actually, I'm going to pause it and fix it, so there's going to be magic here. Okay, so the answer is actually 4.93 liters of oxygen per minute. All right, now let's say you're doing the same treadmill test, but in this case, we've got to change the numbers a little bit. So we're going to say the percentage of carbon dioxide is 0.04%, because that's what it is. But you're actually exhaling 6% of 6% oxygen. How much CO2 are you producing? So again, it's a similar formula, but in this case, you would actually be breathing out 5.96 liters of CO2 per minute. Okay, so that's how we calculate VO2 and VCO2. And just to summarize, VO2 is the amount of oxygen you're using, not breathing in, not how much you're getting into your bloodstream, but it's the amount of CO2 or oxygen that you're actually using. Whereas the VCO2, or volume of carbon dioxide, that's the amount of CO2 you're actually producing. We usually use indirect calorimetry as opposed to direct calorimetry, because direct calorimetry is very, very difficult, and indirect provides a pretty reasonable estimate.